Good day. I am Ma'am Jenny, your science teacher, and I am here again to help you learn science concepts. Last time, we talked about Newton's first law of motion. Can you still recall what is it? Very good. That is the law of inertia. Today, we will be discussing about Newton's second law of motion. Are you excited? So come and join me for our today's session. Today, we will be discussing another law which was formulated by this man who is flashed on the screen. Can you recall what is his name? Very good. He is Isaac Newton. We have learned on our previous lesson that Isaac Newton formulated the laws of motion. Before we discuss the second law, which he formulated, let us have a recall of what we have learned on our previous discussions. Let's start with balance and unbalanced forces. When there is an unbalanced force acting on an object, that unbalanced force causes the object to change its motion. That means to accelerate. When the forces acting on an object are unbalanced, the net force on the object is not equal to zero. When the forces acting on an object are balanced, the net force on the object is equal to zero. Newton's first law states that every object continues in a state of rest or of uniform speed in a straight line unless acted on by a non-zero net force. Let's take a look at the shoppers. Can you determine which among the shopping carts is the heaviest? How? Write down possible ways to determine which is the heaviest without actually weighing the cards in a weighing scale. So this is your challenge. You have to determine which among the shopping carts is the heaviest without actually weighing the cards in a weighing scale. Do you have your answer now? Okay. Newton's second law will help us figure out the answer. The first law explains what happens in the absence of the external forces. There is no change in an object's motion. But when an object speeds up, slows down, or changes direction, then there must be an external force acting on it. This is the essence of the second law of motion, which can be stated as an object's acceleration is directly proportional to the net force acting on it and is inversely proportional to the object's mass. The object always accelerates in the direction of the force or of the net force. Remember that the net force is the sum of all forces acting on it. In Newton's first law of motion, if the net force is equal to zero and the object is at rest, it will remain at rest. Whereas if the object is in motion, it will continue moving along a straight path. It will not speed up, it will not slow down for as long as there is no external force. But here, in Newton's second law of motion, we have have several quantities that we have to consider. That is the net force or the external force that will act on the object and the mass of the object. Since a non-zero net force acting on an object will cause the object to accelerate, when we say accelerate, it will change in motion. How much the object will accelerate depends on the strength or magnitude of the net force on the object as well as its mass. Take note of this. For Newton's second law, we will be focusing on the strength or magnitude of the net force on the object and the mass of the object. So if there is a net force on an object, then the object must accelerate in the direction of the force. If the net force which was exerted is vertical, the object should move vertically. While if the net force exerted is horizontal, the object should move horizontally. For the equation or for the formula in solving acceleration, we have net force or the sum of all forces divided by mass, or A is equal to F net divided by M, or F net is equal to MA, where A stands for acceleration, F net the sum of all forces acting on an object, and M is equal to mass. Let us analyze this illustration. As you can see, there are two men pushing same cart, an older and a younger man. A younger man produces a smaller force, while an older man produces a larger force. The weight of the cart that they are pushing is equal, but the amount of force that they are exerting is not equal. Therefore, if the amount of force is directly proportional to acceleration, then therefore, the larger the force, the greater its acceleration. The smaller the force, the lesser its acceleration, because acceleration is directly proportional to the net force acting on it. Whereas, for the second picture, you have here the same boy with the same amount of force, but one cart without groceries, while the other cart is full of groceries. Same amount of force, but the mass is not the same, because acceleration is inversely proportional to the object's mass. The larger the mass, or the more mass an object has, the lesser its acceleration. Common sense will tell us that mas mabigat na bagay, mas mahirap pagalawin. Whereas, smaller mass, greater acceleration. Dahil mas madaling itulak yung bagay na magaang. So, let us have a sample computation.
Let me help you solve problems in acceleration. But before that, let us read the problem again. The driver of a 1,500 kilogram dump truck exerts a sudden brake with a force of 4,500 Newton. Calculate the acceleration of the truck upon the sudden brake. In solving problems or word problems just like in acceleration, the first thing that we have to analyze on the problem is the given. So based on the problem that we have read, our given are the following. We have 1,500 kilogram and 4,500 Newton. So that is our given. You have to remember that kilogram is the unit of mass, while Newton is the unit of force. Now, the next thing that you have to consider in solving problems just like this is you have to determine what is asked. In this problem, we have to solve for the acceleration of the object. So we are looking for acceleration. So on our previous discussion a while ago, we have learned that acceleration or the formula of acceleration is equal to net force or F net, the sum of all forces, divided by mass. Acceleration is equal to net force divided by mass. Next is we have to substitute the formula with the given. So the net force is 4,500 Newton divided by 1,500 kilogram. So 4,500 Newton divided by 1,500 kilogram. So we have 3. So this time we will find out what is the unit of our answer. We already know that the unit of acceleration is meter per second squared. But by canceling units, let us find out how we can get the unit which is meter per second squared. Remember that Newton is equal to kilogram meter per second squared. The unit of mass is kilogram, then you have to divide kilogram meter per second squared divided by kilogram. So you have to cancel kilogram and kilogram, then you have meter per second squared. So our unit is meter per second squared. So just remember the mnemonics, which is G A F S A or GAPSA. G stands for given, A stands for what is asked, F stands for formula, S for solution, and A for the answer. Just make sure that you have read what is the question on the problem, or if there are other questions on the problem, you have to answer that question. For our next problem, medyo mahaba yung problem, so please bear with me. There is a build-up of traffic along FF Halili Avenue in Badbagin, Santa Maria, Bulacan, going to NLEX because of an accident between a car and a truck. Sanin tayo dyan, lagi traffic sa may papuntang Bukawi. A crane was used to lift the 50-kilogram car. If the force exerted by the crane is 100 Newton, what is the car's acceleration? Remember our mnemonics. You have GAF, SA. Given, what is asked, the formula, the solution, and the answer. For this problem, our given are the following. The mass of the car is 50 kilogram. Always remember that the unit of mass is kilogram. Kilogram is the unit of mass. Whereas for the given net force, we have 100 Newton. Newton is the unit of force. The unit of force is Newton. Then, we have to look for or solve for the acceleration of the car. Our formula is acceleration is equal to net force divided by mass. Let's substitute the formula with the given. Acceleration is equal to 100 Newton divided by 50 kilogram. 100 divided by 50, easy. Dali-dali lang, di ba? You have 2. Newton is also equal to kilogram, meter per second squared, divided by kilogram. So you will cancel kilogram and kilogram. So the unit is meter per second squared. So the answer, the car's acceleration is 2 meter per second squared. Easy, isn't it? And for the last problem for this session, we have what is the acceleration of a 1,000 kilogram truck if the force acting on it is 2,000 Newton? Can you identify what are the given in the problem? Very good. So we have 1,000 kilogram, that is the mass, and we have 2,000 Newton, the net force, or the sum of all forces. Next is, we have to write what is asked. So, alam nyo na yan. We have to look for, or solve for, or compute for the acceleration of the truck. Then, the formula. Can you recall the formula? Very good. You have acceleration is equal to net force divided by mass. Then, if we are going to substitute it with the given, we have 2,000 Newton divided by 1,000 kilogram. So, 2,000 divided by 1,000, you have 2, and our unit is, very good, meter per second squared. Do you have any question? I know you can solve the next problems.
Now, there are times that instead of computing for acceleration, you have to compute for mass, or you have to compute for the net force. Just remember the given formula here. If you have to compute for mass, you have to use the formula net force divided by acceleration. Whereas, if you have to compute for the force exerted, then you have to use the formula acceleration multiplied by mass. So this time, let us talk about free fall. I have here a problem. An elephant and a mouse step off the roof of a 20-story building to see who will have a greater acceleration. They both have speedometers so they can tell their speeds. Neglecting air resistance, what will be the reading on their speedometers after 5 seconds, 7 seconds, and 9 seconds? So here is our situation. So merong elepante at daga. So remember their sizes. Elephant is a huge mammal, an animal. May kalakihan yung elephant. Medyo may kaliitan as compared to the size of an elephant. So, nandun sila sa 20-story building, sa 20th floor. Gusto nilang malaman kung sino ang may mas greater ang acceleration. So, to check that, naglagay sila sa katawan nila ng speedometers. I know that you are familiar with speedometers. Kung sumasakay kayo sa mga vehicles, especially sa mga cars, pag nasa unahan kayo, or even sa motorcycle, meron kayong makikitang gauge doon na pumapalo pagka tumatakbo yung sasakyan for us to know the speed. So take note, you have to know the speed, or they want to know their speeds after 5 seconds, 7 seconds, and 9 seconds. But there's a twist. Kung twist nga bang matatawag, that is neglecting air resistance. We know that kapag may bumabagsak na balahibo or dahon, kapag mahangin, medyo umiimbay-imbay siya or nagbabago-bago siya ng direksyon. But on this experiment, if we can call this an experiment, sa gustong gawin ng elepante at ng daga, we will neglect air resistance. So, dapat wala siyang effect ng air. Sino kaya ang mas may mataas na record sa speedometers? Sa speedometer nila after 5, 7, or 9 seconds? Is it the elephant or the mouse? You make your guess. Do you already have your answer? Okay, let's find out. Falling down. Gravity, as we all know, acts on falling objects, making them accelerate. Pag naghagis ka sa taas or pag bibinitawan kang bagay, babagsak siya because of the pull of gravity. For all objects, a force is required to cause acceleration. All objects will accelerate when there is an external force acting on it. When you drop a stone, its speed keeps on increasing until it hits the ground. Bakit kaya ganun yung statement? Pag nagbagsak ka or nagbumitaw ka ng bato or kahit na anong object, yung bilis nito, pabilis ng pabilis hanggat hindi pa ito bumabagsak sa ground or sa lupa. Why is that so? When the only force acting on an object is gravity, it is in free fall. If we neglect air resistance, kapag tatanggalin natin yung air resistance, ang force na lang na nag-a-act dun sa object ay gravity. So, if the only force acting on an object is gravity, we can say that it is in free fall. The speed of a freely falling object increases by 10 meters per second for every second that it falls. It means that on the first second of its fall, sa unang segundo ng pagbagsak nito, meron itong bilis na 10 meter per seconds. Remember that the unit of speed is meter per seconds, whereas the unit of acceleration is meter per second squared. On the next second, sa pangalawang segundo, it is 20 meter per second, 30 meter per second on the next, and so on. So, balikan natin. Pag walang air resistance at gravity lang at ang nag-a-act dun sa bumabagsak na object, sa unang segundo ng pagbagsak, ang bilis niya ay 10 metro kada segundo, 10 meter per second. Sa pangalawang segundo, yung 10 magiging 20 meter per second. On the third second of his fall, magiging 30 meter per second, and so on. Bakit kaya ganon? In other words, freely falling objects have an acceleration of 10 meter per second squared. That is the value of acceleration due to gravity. So we can say that freely falling objects hindi na-apektuhan ng air resistance at tanging gravity lang ang nakaka-affect dito ay mayroong acceleration na 10 meter per second squared at tinatawag ito acceleration due to gravity. Nag-a-accelerate siya, nagbabago yung bilis niya because of the pull of gravity. The actual value is 9.8 meter per second squared, but we round it off to 10 meter per second squared for convenience in computation. Mas madali natin makakompute kung 10 yung gagamitin natin. But remember, the actual value is 9.8 meter per second squared. Okay, let's have the computation. On the 5th second of the elephant's fall, ang kanyang speed sa speedometer niya ay 50 meter per second. If we will follow the acceleration due to gravity's value, which is 10 meter per second squared. So, kada isang segundo, madadagdagan siya ng 10 meter per second. Therefore, sa pang 7 segundo, what is the speed of the elephant? Pala muna tayo sa mouse kung ano yung marirecord sa kanyang speedometer. Sorry. So, tama. It is also 50 meter per second. Regardless of their masses. Bakit? All objects, regardless of their masses, kahit gaano kabigat ang isang object, kung gravity lang ang nag-a-act sa kanya at walang air resistance, all objects will fall at the same rate. So, magsing bilis lang ang kanilang pagbagsak or kanilang pagbulusok. Therefore, after 7 seconds, the elephant's speedometer will have a reading of 70 meter per second. Same as the mouse. Very good. After 9 seconds, magiging 90 meter per seconds, while for the mouse is the same. Now, how about if we will use the actual value? For the elephant, after 5 seconds, you have 49 meter per seconds. That is 5 times 9.8 because 9.8 is the actual value of acceleration due to gravity. 68.6 meter per seconds after 7 seconds and 88.2 meter per seconds after 10 seconds. So the answer for the mouse is also the same. Do you have any question? So the mouse and the elephant will fall at the same rate. Their velocities will be changing at the same rate. Thus, their speedometers will always have equal readings. The mouse and the elephant will have equal acceleration, which is 10 meter per second squared. Again, the actual value is 9.8 meter per second squared. This time, let's have a marble lift challenge. So you will need a wine glass. Your task is to lift marble with an inverted wine glass or a wide-mouthed jar. Tingnan nga natin kung nagawa ng isang estudyante. Let's watch again. So, nakita niyo ba yan? Anong ginawa ng estudyante? Let's watch again. So, the student was able to lift the marble nang hindi nahawakan yung marble by just using a wine glass. How are we going to explain that? That can be explained by circular motion. What is circular motion? A type of motion of an object in a circular path with a constant speed but changing direction due to a net force. Let us watch this. Stunt is the wall of death. So, only professionals can do that. So, yung mga professionals lang yung nakakagawa niya. So, the way that the student lifted the marble by moving the wine glass in a circular path or paikot ng mabilis at constant speed, hindi bumabagal, ganun din yung concept kung paano nakakapagpatakbo ng motorcycle itong daredevil na rider na ito into a cylinder. So, medyo delikado yan. In circular motion, the direction of the velocity changes every point along the circular path. So, we have to bear in mind that when we say acceleration, hindi lang ito tumutukoy sa bumibilis or bumabagal. Pwede rin itong tumukoy sa hindi siya bumibilis, hindi siya bumabagal, pero nagbabago siya ng direksyon. Just like in a circular motion. This change in direction is an indication that the object is accelerating and the direction of acceleration is towards the center of the circular path. Thus, it is called as centripetal acceleration. So, if the acceleration is due to the circular motion, we call it as centripetal acceleration. Following Newton's second law, centripetal acceleration is caused by a net force. We call it centripetal force. Centripetal force is defined as the force that is necessary to keep an object moving in a curved path and that is directed inward toward the center of rotation para hindi ka tumilapon palabas. While centrifugal force is defined as the apparent force that is felt by an object moving in a curved path that acts outwardly away from the center of rotation. Have you experienced riding in a vehicle wherein yung katawan mo ay gumagalaw outward or even inward? You encounter a curved path. So that is what do you call circular motion. That is just an additional topic in relation to Newton's second law of motion. I hope that you learned something, but before we end this session, let us have some questions to answer. Number 1. Which of the following is the most difficult to accelerate? A. 1 kilogram object. B. 2 kilogram object. C. 3 kilogram object. And letter D. 4 kilogram object. Write your answer on your notebook. 5, 4, 3, 2, and 1. Alright, the answer is very obvious. That is 4 kilogram. Why 4 kilogram? 4 kilogram is difficult or is the most difficult to accelerate among the choices because it is the heaviest. We have learned that in Newton's second law, the heavier the object is, it is difficult to accelerate. Next question. According to Newton's second law of motion, acceleration is proportional to force. That means a larger force, A, produces a smaller acceleration. B, does not affect acceleration. C, produces a smaller mass. Letter D, produces a larger acceleration. 5 seconds. 5, 4, 3, 2, and 1. The answer is letter D. Why letter D? If you exert a larger force, you will have a larger acceleration because acceleration is directly proportional to force. Greater force or larger force produces larger acceleration. Smaller force produces smaller acceleration. Number 3. An object was set in motion by a force. What will happen to the acceleration if the net force increases? A, remains the same. B, increases. C, decreases. And letter D becomes 0. Your time starts now. 5, 4, 3, 2, and 1. Answer is increases. Again, force is directly proportional to acceleration. If the net force increases, the acceleration also increases. Okay, I hope you learned a new lesson today. See you again next time.